Yes, Brian.
Are you getting me now?
Yes.
Okay, let's pray. Our Father in heaven, we want to thank you for this glorious opportunity of meeting, and whatever that we are going to discuss today, may it be of importance to the development of education in the country and in the world. For this is my humble prayer in Jesus' name. Amen.
Okay, man. Thank you so much, Mr. Brian, for the word of prayer. Allow me to welcome all the members that are joining in from the different parts of the world. Thank you so much for joining. I want to welcome Professor for this session. Professor, you're most welcome. I want to welcome the representatives from the Ministry of Education and from the National Curriculum Development Center. You are most welcome. And also I want to welcome our friends that are joining in from Zambia, from Tanzania, Rwanda, and Kenya. You are also most welcome. And also the teachers that are joining in from Uganda, you are most welcome for this session. This is our session for this month, and we are remaining with more 2 sessions to go. There is a lot that we have been learning throughout this journey, throughout this season, and I'm very sure there is a lot that you are going to be learning through this session. In case you have any questions, we shall be requesting you to put those questions in the chat, but later on you can as well send the professor a message, or you can send him an email and he will be able to reply to you. Allow me to welcome now the Principal Education Officer in Government Secondary Department at the Ministry of Education and Sports to welcome the members and to officially open up this session. Mr. Ronald Dungu, you are most welcome.
Thank you, Mr. Kaziba. I hope you can hear me well.
Can you hear me? Yes, we can.
Okay, and I just thought that I could give you a background here. Let me see if I can clean my camera. I don't know, I'm at Busubizi Primary Teachers College in Mitiana. This week I have been able to visit 2 primary teachers colleges. And for me, it is exciting that I'm where we train the teachers for primary schools. And that is very critical to us in education. I'm here because we are doing training for local governments on the education management information system. I'd like to thank Professor for continuing to support us as Ugandans, and we are also thinking of expanding this engagement to other countries in the region. But thank you, Professor, for keeping on. It's tiring. I know it is very early in the morning, 7 a.m. of your time, but thank you for keeping us in mind and for the education you offer to us. Friends, ladies and gentlemen, we are happy that we are back, and this is the 3rd time we are here, and we still have some few more times to go before this pilot ends. We are trying to see, is it possible to do professional development, online professional development? Is it possible to have Professor Padhu or any other expert across the world to share with us what they know and to redirect the education in our country? I think we have demonstrated that it is possible. Now what is left is whether we ourselves are learning and transforming the education in our own context. So we will be able to discover that after some time when we hear your stories of what you are doing. But Professor, thank you for joining us once again and for the preparations that go behind the doors for you to be able to come again and present to us. I wish everybody the very best of the session, and we will catch up again at the end of this session. Thank you, Mr. Kaziva and your team for organizing. And for us at the Ministry of Education, we are happy that this is happening, and all my colleagues, all our leaders, the ministry are waiting for the results that are coming out of these pilot sessions. Thank you, and over to you, Mr. Kaziva.
Okay, thank you so much, Principal Education Officer in Government Secondary Department, for the opening remarks. And we want to welcome those who have just joined us. Thank you so much for joining this session. Allow me now to welcome the professor to take us through his presentation. Professor, you're most welcome.
Okay. Let's see here. Let me try to share my screen. Let's see here. Okay, please let me know if you're able to see my screen.
Yes, Professor, we can.
Okay. Okay, so let me minimize something. Okay, and I'm also going to open the chat just in case so I can see what you're typing and all that. So, okay. First of all, thank you again for having me back to engage you all, because, you know, this is just the beginning of potentially a long-term collaboration that we can actually all engage in. So I'm going to just stop my video in just a second and then continue. So can I ask you before, do you see just my screen as in just the first page, or do you also see the chat that I'm opening?
The chat is not there, but we can see the.
That's actually good to know. Okay, good. Thank you. So, so I thought I'll share with you some ideas on, you know, something that is very important in the world right now, which is about data, and with the revolution on ChatGPT, I'm sure you all have heard of ChatGPT. Can I see on the text how many of you have used ChatGPT? Just say yes or no. Have you heard of ChatGPT? Yes or no on the chat. Okay, so I see yes, a lot of yes. That's great. Not okay. So I see a lot of yes. So this is great that you know about ChatGPT and you've probably used it also. So next time when the focus will be on ICT, and there we'll probably do some ChatGPT and all that. But today I wanted to just focus our attention on understanding about data and how it actually comes across the entire curriculum. And as always, I want you to open up your minds, you know, because I'm going to engage you in some activities and all that. So let's start with an activity that involves mathematics, okay? Because I know you're all eagerly waiting for your results, but there is a reason why I'm doing this. So let's start with a simple problem that could be in your secondary education, or you know, lower secondary, for example, or upper secondary. So here's a triangle, and the data is given to you in terms of the vertices, and you're asked to find the area of this triangle. Now, you're all welcome to use a piece of paper and pencil and actually calculate the area. And let's see how fast you can tell me what the area is. And you can type on the chat. I'm just waiting. Okay. So, and for those of you that are not working on it, you're welcome to tell me what you would do in a traditional mathematics class in lower secondary. What do teachers teach to help students to solve this problem? It's finding the area for triangle. So Stephen has 18, okay. And Stephen, as you say the answers, you can say, I used this, I used that. So I know what you're using also to find the answer. So Stephen quickly has an answer of 18. Other people on the call, I know there are several of you, and this looks like, oh, looks like a simple problem, but it's really not simple. So I'm waiting for, it's not to test your mathematical skills, but yeah, okay, Hero's formula, very good. So Sarah talks about Hero's formula. Hero's formula, it's actually Heron's formula. Let me write it on the chat also. It's Heron's formula. Heron's formula is one which involves the semi-perimeter. And so you have to find the semi-perimeter. But to find the semi-perimeter, Sarah, you have to actually calculate the distances of each side. That's going to take you some time. You're going to use the distance formula, and you're going to find the distance of one side, distance of the other side, distance of the third side. You got to find the perimeter, and then you got to find the semi-perimeter, and then you got to use the formula square root of s times s minus a times s minus b times s minus c. Okay, that's one. Stephen used a diagonal approach. I have no idea what a diagonal approach is, but it's interesting that, can you speak, Stephen, what a diagonal approach is? Oh, I see. Maybe you use the matrix approach. Is that what you did? Like a
yes, that's the one.
Very good. So clearly, what you just did demonstrated what typical students also tend to do is, what formula should I use to do the problem? And unfortunately, that is one of the biggest challenges in our educational system, is people are always looking for a formula to solve the problem. And because you do that, that is what is called as procedural learning. Most of the educational system in many countries that I've worked with, they're very procedural. But procedural learning is only helpful for students that are memorizing things. Now, because Stephen memorized a formula, which is x1 times y2 minus y3 plus x2 times y1. So essentially, or using determinants and things like that, he was able to tell me an answer. Now, I'm not telling if Stephen got it correct or not. The rest of you were very clever. You didn't give me the answer, but you just said, I'll use Heron's formula. I was expecting an answer. Given that you're all educators, I was hoping that at least besides Stephen, others will be bold here to give me an answer. You did not. You just said like, oh, use the formula. So unfortunately, that attitude will translate down to students. Now, let me explain why I'm saying this. And let me actually also say what Stephen did. Stephen used a very popular formula to find the area of a triangle when you're given three coordinates, x1, y1, x2, y2, x3, y3, and there's a formula. So the kids that can memorize it, they can do it. Of course, if they know determinants, they can do it. And the rest of you that said Heron's formula, you still haven't given me an answer. I'm waiting for an answer. I'm actually surprised that I don't know what you're doing listening to my talk, but you're also going to be working, because remember, you are students today. I'm the teacher. So I was expecting that you're also working with me. But I see only one student that was bold enough to give me an answer. So let's think about it. So Stephen used this formula, for example, to find the area of a triangle. What does that mean? Basically, what he did was he said x1 would be 7. Let's say 7, 5 is x1, y1. 3, 9 is x2, y2. 2, 2 is x3, y3. He simply plugged it into the formula. And Stephen, unfortunately, you did it right, almost, but then Ronald has the correct answer. 16 is the correct answer. Maybe you did a small typo, but I give you credit for being bold and answering. It's not about the incorrect answer. You used a formula, but then maybe you did a silly mistake somewhere. And Ronald was very careful giving me the answer, but I don't know what technique Ronald used. So, Ronald, did you use one of the formulas? Just curious. If you just tell me if yes, I used
I used area of a big rectangle minus area of 3 small triangles.
So now let's think about what Ronald just did. So the two ideas that you all present, I love the way. So I exactly wanted to get there. So I'm glad this was not at all planned, by the way, but between Ronald and I and Stephen. So I want to tell you that many kids, if you teach this way, they're going to be looking for or memorizing formulas or forgetting formulas, and they don't know what to do. What Ronald did was something very clever. He said, what if I actually draw a rectangle around the triangle? Now, if you look at the rectangle very carefully, there are three parts to it. There's a, if you look at it carefully, there's a right angle triangle there, whose area is very simple. You don't need to wait. You learn this in middle school. So half times base times height. That's 7 divided by 2. There's another area which is half times base times height, half times 4 times 4. And there's another area which is half times, again, base times height, which is half times 5 times 3. So now that I know the areas on the outside, I can simply add those areas. And I know the area of the rectangle, so I can just take the area of the rectangle and subtract. I know the area of the rectangle is 35. I can add the areas of the outside and simply subtract it. So what I want you to understand here is the approach that Stephen took, which is conceptual learning. And somebody must be muting whoever is trying to speak. If you can mute your side, that'll be great. So I wanted to just give an illustration of, okay, somebody is talking. So let me just make sure we mute the person who's talking. So I'm not sure who's talking. Okay. So what I wanted you to learn is two big words: procedural learning, conceptual learning. So what Stephen and many of you in the call demonstrated is procedural learning. This is unfortunately only going to help 1/3 of your students. What is needed is conceptual learning. And this is very, very important in mathematical thinking. Okay, good. Now that you learned something today, let's keep going to the next one. Now, actually, Ronald also put another idea there. So you can see the little boxes areas. You could add up those boxes also, and that's another way to actually doing it. Unfortunately, you don't know if it's half a box, quarter of a box, and things like that. So this is data that was given to you in the form of vertices, and you were asked a question, but then you needed to really know how to solve this problem. So let's continue to go forward. So let me take you backwards to maybe middle school. So that one was mathematical foundations. So let me ask you this question. So if Michael Jordan, you probably recognize this guy, and if Michael Jordan scored 20 points in the first game, 24 in the second game, 32 in the next game, 22 in the next game, 28 in the next game, so 5 games, what should he score in the 6th game to get an average of 25? I'm going to wait again to see how we solve this problem, or type on the chat, what did you do? Go ahead. I'm just curious about your thinking. Don't worry. I know I always challenge educators because I want you to come out of your fixed mindset to a growth mindset. That was the whole point of my being the teacher today and you being the students. So please take off your ego hats and all the other things, and let's learn together just like students. So how would you do this problem? This sounds like a statistics problem, but it's very simple. And I'm going to use the concept of what? I am expecting some answers online. I don't see anybody answering anything. This is not even a lower, I mean, it's much, it's beyond, before lower secondary, I would say. Anyone on the chat? I'm looking for answers. I don't see any. The question is very simple. It's a basketball game. There are 5 games that Michael Jordan scored 20 points, 24 points, 32 points, 22 points, and 28. Fred has an answer. He says 24. Okay, I'm looking for other answers. 24. Ronald says 24. Now, unless I made a mistake, Fred, just curious, you can type on the chat, please, how you did it. So what is the mathematical concept that you used? Patience is saying 23. Just type on the chat, what concept did you use? Or statistical concept? The word that I'm looking for. Well, the word is in the question. The question said average, right? So you want an average of 25. Now, here is how most kids will solve the problem, and work with me here. So immediately they'll say, X is exactly. So Sarah is saying, so they say X is the unknown. So 20 points plus 24 points plus 32 points plus 22 points plus 28 plus X divided by 6 games should be 25. And then Wow, you, Kiria, I don't know how you get a 20.8 in a basketball. That's very interesting. I don't know how you get a 0.8 of a basket. That's a interesting question to work with the kids on. So now that you do this, then you cross multiply the 6, and then you add up all these things, and then subtract, and then find x. Now I want you, that's procedural learning. Let me now give you another simple way to think about it. Now, he scored 20, 24, 32, 22, 28, and you wanted to know how much he should score on the last game. Now, let me ask you this. In order to get an average of 25 in 6 games, what's the easiest way to get an average of 25 in 6 games? What is the easiest way to get 25 as an average in 6 games? Now, the techniques that I'm presenting to you, I know you have the answer. Answer my question, please. What is the easiest way to get a 25 average in 6 games? What is the easiest way I can get an average of 25 in 6 games? I'm still waiting. I don't see a good response. Now you're talking about median and all that, Stephen. So arrange them in, okay, that's fine. And then, but my question was much simpler. How do I get an average of 25 in 6 games? What is the easiest way I can actually get an average of 25? So it's interesting. I asked a very simple question and you're all struggling already, just like children. So one of the easiest ways to get a 25, there it is. So is to get 25 in every single game. Don't you realize that? So if you get 25 in each game, you obviously get an average of 25. Why don't we start there? Now, let's look at the first game. First game, you scored 20 points. Well, I would have loved to score 25 points, but that's 5 points less. Look at the second game. I scored 24 points, but I would have loved to score 25 points. That's 1 point less. Look at the third game, 32, and is 7 points more. So I do a simple math and see how much more or less each one is. So the first one is -5, second one is -1, third one is +7, next one is -3 and +3. I simply add all of them and immediately get like 1 more. So if I have to have 1 more to get an average of 25, I need to do 1 less. So the answer is 25 minus 1, 24. I don't know if you got what I just said. It's one of the most powerful ways to find average. Unfortunately, we don't teach children this way. We just ask them to memorize a formula. So what I just demonstrated is one of the most powerful ways to work with averages. Unfortunately, there are no textbooks that explain this properly. So if you want to improve your curriculum, move beyond procedural learning to conceptual learning. It's very, very important. I wanted to give you 2 examples. The first example, yes.
Professor, I did the would-be opposite.
Yeah.
I don't know if it's opposite. I simply
subtracted.
I simply took 20 as the basic.
That's a fantastic idea because you took the last one.
0,
yeah. You got
0, then 4,
yeah, 12,
like that.
And minus, so that's also great. That's great. But still, you kind of use the formula probably,
yes.
Ronald.
Yes, but, I used the formula.
But at the end, right? But you used this, but what you did was demonstrated in procedural learning. You made your life easy and then did the problem. What I'm explaining is I don't need any formulas. Look at the way I was thinking. It's called load balancing. So, this one is less, this one is more, this one is less, this one is less, this one is more, and I adjust it. That's all it is. So it's about conceptual learning. Kids will pick this up very, very fast. No formulas needed. So this is exactly why I wanted to start at this point. Okay. So let's continue to go. Let's go. I'm showing a chessboard here. I'm sure many of you know chessboard. I may have done this before, but I'll do it again. How many squares do you see on this chessboard? Go ahead, type on the chat very quickly. How many squares? It's a typical chessboard. How many squares do you see on the chessboard? Go ahead and type on the chat. Now, don't be afraid. Like, nobody, if it's wrong, it's wrong. It's okay. No problem. Brian says 64. Keep typing, please. Fred says 64. There's a whole bunch of 64. I'm so happy to see that educators can also make quick mistakes. My question was, how many squares do you see? And Sarah suddenly sees 65. Sarah, any reason why you saw 65? And we'll hold on to Steven's answer. Any reason why you saw 65? I'm surprised. Like you just surprised everybody else. So did Ronnie. So it turns out that the basic thinking that most of you did, you said there's 8 squares horizontally, 8 squares vertically. So it's 8 times 8, it's 64. That's great. Most people do this, and this is called pattern recognition. But people like Sarah and Ronnie, they come in and they see a green square outside the whole square, the big square, I mean. So that requires critical thinking, thinking outside the box. So it's not 64, but they claim it's 65. But wait, is this 65 only, or are there more? But before we do that, you need to know that we learned about 2 very important skills that people should have: pattern recognition, critical thinking. And then in order to understand a problem, to see what Stephen is saying, 204, and many of you are like, what is Stephen saying? He must be totally wrong. But let's check. But before I do that, he probably did something that you guys did not. Let's teach you problem decomposition, one of the most powerful things to think about. All these are important competencies. So what you do is we solve a simpler problem. So instead of an 8 by 8 square, why don't we take a 3 by 3 square? Now, those of you that said 64, you're going to quickly say, oh, that's 1 by 1 squares. That's 9 of them. So you probably stop at 9. But then the people like Sarah will identify the 3 by 3 squares. But what happened here? I went from 1 by 1 to 3 by 3. I missed something. I actually missed the 2 by 2 squares. And it turns out there are 4 of them. And so for a 3 by 3 square, I have 9 1 by 1s. I have 4 2 by 2s. And I have 1 3 by 3. That requires creativity, the next important competency. So, but if you really think about what is the numbers 1, 4, 9, they're nothing but perfect squares. What was the question I asked you? How many squares do you see? So none of you told me these are sum of perfect squares. Yet, we teach this in high school, in secondary education, because there are many, many more squares, which we do not see. I said, how many squares do you see? And now we do what is called as abstraction. That is, you did a smaller problem, now we do a bigger problem. So let's talk about, and then we thought about this in a very algorithmic way. So you got the 1 squares, the 2 squares, 3 squared. Now, if you actually do this problem, it's actually 1 squared plus 2 squared plus 3 squared all the way to 8 squared. And you will know why Stephen was kind of right. So the question was, how many squares do you see? What did we learn here? We learned about critical thinking, creativity, communication, collaboration, because you all communicated with me on the chat. Those are the 4 important 21st century skills. We also learned about pattern recognition. Many of you made a mistake by just saying 8 by 8. You learned about problem decomposition, going from an 8 by 8 to 3 by 3, solving the problem for 3 by 3 and then coming back. And then algorithmic thinking, and then abstracting from computation. So these 4 skills are very, very important, and they're called computational thinking. So today I started off with mathematical foundations. Then I moved on to statistical thinking, and now I did computational thinking. So now what I want to do is I'm just going to, actually, let me continue, full screen it again. Let me make sure. Could you please confirm that you're still seeing my screen? I just want to make sure. You all see my screen? Just say yes on the chat. Yes, okay. So, so we learned about all these things today, just, in a matter of seconds. You learned like a student today. Yet, we go into the classroom and teach formulas. We say, oh, I'll teach you like 1 squared all the way to n squared is n times n plus 1 times 2, n plus 1 divided by 6. And then what do? We teach them mathematical induction. The kids are sitting there and thinking, why did this guy not bring a chessboard into the classroom and motivate this discussion? And that makes you a better teacher. I hope you understand how to actually grow into a better teacher. That was my point today, is don't just feed formulas and just promote that little Johnny that can memorize everything and get the highest scores in the exams. Also promote those kids that can think outside the box. Unfortunately, this doesn't happen because most educators don't think outside the box, because you guys think traditionally, like we saw today. Most of you are wedded to formulas. So stop doing that, go beyond formulas, okay? And that's the only way to improve your own next generation workforce. Okay, so the 4 important skills that I talked to you today is problem decomposition, abstracting from computation, pattern recognition, and algorithmic thinking. This is called computational thinking. So I'm going to skip this problem because I'm watching time, and we'll bring it next time. So what I want to talk about in the rest of the session is about what is happening in the state of Virginia, which is one of the states in the United States. I was very fortunate to be on the task force with the Department of Education, just like the Ministry of Education there, and create the first ever high school data science class in the entire state of Virginia. Now, 400 students have already taken it. Many more students are taking it again. This year. What you're seeing here is the first cohort of teachers. These are mathematics teachers, computer science teachers, statistics teachers. They are transforming themselves to be data science teachers. So we have created a complete curriculum, and hopefully I can work with Uganda to actually create the idea of data science, because that is the future, my friends. In terms of, unfortunately, we don't teach this very well, okay? I request you to rewind the previous screen. I'm not sure what you mean. Are you able to see my screen or not? If you say yes, I will continue to go on. Are you all seeing a picture of which says Virginia?
Yes, we are seeing.
Okay, good. So from here on, I'm going to get you guys to think about data. But before I wanted to get you into this, I wanted you to first understand the differences between procedural learning, conceptual learning, and all the different competencies. Okay. So Ronald and others who are working with the ministry, this would be something very big for Uganda. If we create the first ever high school data science class, I can tell you how things are going to change, because data science is not just going to serve those mathematics students or the science students or the statistics students. It's also going to serve the students that want to go into the restaurant industry, want to get into the fashion industry. Why? Because I would like to know which coffee sells the most on a Wednesday at 2 p.m. If you can figure that out using data, then you will be hired big time by the coffee company. So, so you have to really think about how to bring data to excite students at all levels, at all disciplines, so social sciences. So we have created this class using this idea of, getting all students to learn how to collect data, whether it's health data or business data or traffic data, whatever it is. Every kid must know how to actually kid should know how to actually collect data. First of all, they have to have a question that they need to solve. Then, for example, maybe bananas, how many bananas, and or food wastage or whatever it is. But then they have to collect data. Then they have to process the data. Then they have to visualize data and represent it. Then they have to model and analyze it and then communicate the data. So every student in Virginia is given the option to understand data science using this thing, what we call as the data cycle. I wish we can, once again, working with the Ministry of Education in Uganda, hopefully we can create this for the first time ever, maybe first time in an African country, this course is created, and then maybe other countries will follow. So let's talk about data. Now, data could come in many different forms. Data could be completely unstructured. It could be sorted, like the colors that you're seeing here. It could be arranged. It could be presented in a visual way. It could be explained with a story. It could be very actionable. So let's start with a story, okay? Here is data that is presented in a very interesting way. Let me just tell you the setup. This is the march of Napoleon Bonaparte, who took his army from between Poland and Moscow and then came back. Given that situation, what all do you notice in this picture? What all do you notice in this picture? What do you notice in this picture? Please tell me everything that you think. What do you think are these big bands, like the brown band that is becoming thin and then it's coming back as black and all that stuff? What do you think that is? Anyone wants to take a guess? Once again, the setup is Napoleon is taking his army between Poland and Moscow and bringing back. This graph, by the way, is called the most popular data visualization graph. What is going on here? Anyone? You may have heard this story, but anyone knows what this? Very good, Caroline. Thank you. So the graph actually shows a path from east to west, okay? Geography. So it touches geography. What else do you think? What do you think this band is? This big band is that goes, that keeps thinning and then comes back as black, very thin. Not the path. Why is the path becoming thinner and thinner, Pico? What do you think it's becoming thinner and thinner? This is the creativity part. Just go crazy in guessing. Any ideas? Well, let me tell you the story. It turns out that Napoleon started off with 422,000 army. And as he went through to Moscow, it became 100,000. And then when he returned, it became 10,000. So what you're seeing here is the number of soldiers represented by that big band, okay? And it shows the number of soldiers. Now, Caroline already said east to west, so it shows geography. It shows number. Now, let me ask you another question. Look at this little piece here. You've actually, look at this piece where November 28th, the bottom to December 6th, all of a sudden, 8,000 people died. Actually, no, this year, 55,000 suddenly came down to 20,000. What could have happened there? This piece here, 55,000 came down to 20,000. That's a big, lots of soldiers died. What do you think is going on there? You see, there is a little river right there. It's called the Berezina River. It turns out that the Berezina River froze. And because the Berezina River froze, many soldiers died. Now, how do I know the river froze? Look at the bottom. There is a temperature graph there. So this is why this particular picture is such a powerful picture for data visualization, where it talks about the number of soldiers, the geography, the history, the even verbal on the top, even the temperature graph. So 6 different dimensions in the same graph. So such a powerful graph, right? So in terms of explaining to the students, and it's all STEM and STEAM, for example, right? So you're introducing arts into it. So, location, direction, number, and so many things. So visualization is a very important thing when it comes to data. So let me do one more story for you. We all know the Sustainable Development Goals. Let me take, quality education. So here is a picture, and the pedagogical practice that I want to introduce to you today is, what do you notice and what do you wonder? Can you please type on the chat, what do you notice and what do you wonder? You say, I notice a dash. I wonder what those dash. Go ahead, type on the chat, please. Go ahead. What do you notice? Just say a simple thing like, oh, I see a dash. What do you see? So remember, this is data storytelling. Okay, good. Pico is saying, I notice a work plan. Very good. It could be like a civil engineer's work plan. What else do you see? Other things. I notice homesteads, roads lead to them. Very good. I see a plan. I'm assuming when you say plan, you mean like a map. That's hoping that's what you mean. A road network. Very good. Very nice. It's a road network. You're all right. What do you wonder about? What do you wonder? You told me what do you notice. What do you wonder? Anything that is bothering you? Where was it taken from? Very good question. Where did it come from? It's London, Soho, London. What else is bothering you? Anything else bothering you? I wonder what it means. Very good. How it was taken. Very good. All great questions. So I wonder why it's incomplete. Okay. Does it not bother you that there are those little black things there? How many of you are noticing that the black things that are popping out, and those types of things? But you've done a really good job at noticing. I would like to get some math wonderings also. So very good. So it turns out this graph has to do with this guy. Anyone recognize this guy? This guy is so important in history because of something that we all went through called COVID. So he's known as the father of epidemiology. And his name is John Snow. Now, John Snow was very influential. If you did not know, he was the one who stopped a very important disease, not COVID. Anyone? No, a disease that he helped to stop? He helped to stop cholera. So it turns out that in 1800s, he went door to door when people were dying of cholera, and he collected how many deaths happened in each household. And the black dots that you're seeing, so you see there is a big black line there. That is his representation of how many people died in that household. For example, the long black line is 18 people dead. So this is his representation, but it's very powerful that he showed it this way. Now, but John Snow was also trying to have a battle between himself, his ideas, and the doctors, because he said these deaths are happening because of water, people drinking, infected water. And he talked about virus and all that. So you already see we went from history to geography to biology now, right? So, but the doctors did not want to agree to his theory. His theory was it's spreading because of water, but the doctor said, no, it's not water, it's miasma. Now let's talk about English. You guys speak English. What does miasma mean? Literacy, miasma. So they said it's because of miasma. Anyone knows the English meaning for miasma? I'm waiting. Anyone knows the English meaning for miasma? Okay, if you did not know, it's toxic air, bad air. So the doctors in that times said they argued against John Snow, saying the disease is spread from air. John Snow argued that it's spread from water. Now, the doctors did not want to agree to John Snow because when you think of water, you're thinking of urination, fecal, all these bad things. So they did not want to associate it with water. So John Snow was a single person to prove somehow how this thing happens. So what he did, he identified that wherever the deaths happened, he found a water pump. And he wanted to show that, these water pumps may be the ones that are, some of the water pumps are the ones that are deadly here, causing the whole cholera deaths and all that stuff. But he had to prove it. And this is where he used one of the brightest ideas. This is back in 1854. Now I'm going to ask you a very simple question, which I'm going to type on the chat. Back to mathematical thinking. What is the definition, I'm typing it also, of a line that is perpendicular to another line and bisects it? What do you think? On the chat, I'm going to put the question. Let's see how many of you are able to answer this question. What is the definition of a line that is perpendicular to another line and bisects it? The answer is in the question, by the way. Not a median. Median is one type of this, but this is a very special one. And the answer is in the question. Very good, Esther. Exactly. Perpendicular bisector. It was right there in the question. What is the line that is perpendicular to another line which bisects it? I gave you everything that you need. Perpendicular bisector. Now, when we teach high school geometry, we just teach this and then say, if you stand on the perpendicular bisector, you are equidistant from the endpoints. And then what do? We just teach them theorems. We just say, oh, I will teach you SAS, SSS, and all these properties. And then the students have to memorize it and then solve the problem in the exam. What John Snow did was very clever. He used that exact same idea that if you're on the perpendicular bisector on the picture that you see on the top, you're equidistant from the two endpoints. What he did was he saw how many people walk to a certain pump from their house, equidistant. And then he drew the map and figured out that one of the pumps, which is at the Broad Street pump, that caused most deaths. And it was one of the first mathematical data-based arguments that was presented at a court, at an actual court, and won the case. Next time you go to London, please visit the Broad Street pump. And I hope you understood the story today. So, and then of course I can teach you ICT, but I'm not going to waste time today. And then say how the disease spreads and things like that. But what I wanted you to understand today is how do you actually present data as a story? It's very, very important. Okay. Of course, data can be, there are so many different ways to visualize data, either through scatter plots, through, we did CodeApp and we did pie charts and all that stuff, bubble charts, so many ways to do data. And, maybe next time I'll show you how to create some of these things and all that. But there's so many other ways to actually present data. And, it all has a different name, and stem and leaf plot or scatter plot or dot plot or line plot and all that stuff. So here's something about data that you need to be careful about. Now, you're seeing two graphs here. There's shark attack and ice cream sales. And it seems to indicate that if you eat more ice cream, you get attacked by a shark. So it sounds very crazy. Sometimes people present data like this. You're like, what is going on here? This must be something very, really bad idea. And doesn't make sense. Anyone has an idea what's going on here? It's kind of crazy that if I eat more ice cream, I get attacked by a shark. Well, maybe the reasoning here is because it is summer and I'm at the beach and it is very hot. And so there's a lot of ice creams. Exactly, patience. That's the idea. And so there is what we call as in statistics, confounding variable. The confounding variable was temperature. So it's very important. Sometimes this was in the front of a newspaper article. If you present graphs like this, you can confuse people. And if you don't clearly say why this was happening, and the fact that causation is not correlation is not causation is very, very important. Otherwise, people will make wrong interpretation. And that's why politics, the media is very good at twisting and turning graphs, right? So, and then they do this. So it turns out there are 5 super important visualization graphs. And it turns out the graphs are something that we teach in school. It's the pie chart, the bar chart, the column chart, the line plot, and the scatter plot. These are the 5 most popular plots as found by a company called McKinsey. So I'm going to show you some examples of what happens in the workforce. So we are in a healthy industry, 11 performance measures across 3 types. You see 3 columns and 11 performance measures. What's wrong with this presentation of data? What's wrong with this? Can someone tell me what is wrong? So here is a presentation by a candidate coming to the Ministry of Education and saying, hey, I compared 3 different schools in 11 exactly wrong. I cannot read it. You know how many people present like this? Unfortunately, they think they are doing a good job, but they are doing such a poor job at convincing the audience, right? Complex in representation, exactly. Now, this is definitely not a good graph. The next one, our sales has grown considerably since 1996. And here is a picture of a presentation by a salesperson. Is this a good picture? is this good, or what is problem with this graph? Arthur is saying yes, Sarah is saying no. Is this a good way to present a pie chart for our sales has grown? The problem with this picture is I don't know how big the pie is. I don't know what the slice is and things like that. What would be a better chart for showing across time? It doesn't make a good compulsion exactly, but what would be a good chart to actually show across time? Something is changing. It's not a pie chart, but it would be a line plot, right? It would be a line plot. So as 1996 to 2000. So why I'm saying here is you got to find the right plot to do the right messaging. Many people don't teach this part. They just teach like, here is a chart, here is a chart, here is a graph, here is a this, here is a that. And students really leave the classroom thinking, okay, which one should I use when? So you use a line plot when the data has to be plotted across time scale. Very good. So now let me give you another one. These are all poor ways to present. So here is another one. Return on investment on my money is 14%. And I'm, it's a comparison with 2 of my competitors or 3 of my competitors. Is this a good chart? I mean, this is how they're presenting. These are all real graphs presented by marketing salesmen. Another graph that makes absolutely no sense. If you're comparing with companies, a better chart would probably be a bar chart. So when you have data presented over entities, then use a bar chart, not like the line plot, right? Next question. Our market share increased since 1996, and I'm giving you this plot. And I'm looking at this graph and saying, I don't understand where my company is and with the other companies and all that. What would be a better way to doing this? A better way to doing this would be a comparison chart, like a column chart. I can say where my company is and where the other company is, right? So this way I know exactly to compare. So the last one is, I mean, this is something I really, it bothers me a lot. The opinion polls, this is used in politics, show equal support. Why would you waste marketing money to show me that 50% is this way, 50% is the other way? That's the ask your politicians, they will know. Now, so once again, what I want to tell you here is messaging is very, very, very important. You only use a certain chart to depict a certain thing. So if you're doing a time series, or if you're doing component-wise, like if you're talking about, taking schools in Tanzania, I mean, in Uganda, and saying, this many schools are private, this many schools are charter, this many schools are public, this many schools are TVET, this many schools, then you're doing a pie chart. If you're talking about comparison, this one score is better than that score, then you're doing, bar chart and column chart and so on. So you need to know what chart must be used with what messaging. You need to really understand. Unfortunately, the textbooks and the curriculum do such a poor job at not telling the kids what to use. And they just leave learning all these charts. They don't know which one to use when. So we've been very, so you need to really build the curriculum. In our data science curriculum, we show them over time, part to whole, how do you depict flows, how do you to 8 we actually have a basic way. Actually, if I something, I'm going to come back next time to do it. So let me go ahead and finish with this last one. Let me just take 1 minute to do this. I'm going to teach you something called the decision matrix, and this will be very useful when you're picking vendors. Suppose I go to buy a car, and let's say you have a suburban car, Honda Odyssey, a Ford Expedition, and Toyota Sienna, and I have to pick one of those cars. So the way you do this is by writing down the different types of cars on the left side in rows, and on the top, so these are your vendors, what you want to buy. And then on the top, in the columns, you're going to write down attributes, like why do you want to buy? Maybe I want to find a car that is cheap fuel, something that is cheap in price, something that's easy to maintain. I have a big family, I need passengers. So you set up the vendors and you set up the attributes. And then what you do is the following. Then you actually, I want to buy the car that is the cheapest. I want to buy the car I have a big family, so I'm giving a 5 to number of passengers as well. Ease of maintenance is okay. I know how to maintain my car and all that stuff. Those are called weights. And then I give a score. So I take the suburban car and I say, is it cost efficient? Is it fuel consuming? It's very bad, big suburban. So I only give a score of 1. And so I give a score, and those are called a score. And then what I do is multiply the scores. 5 times 4 is 20. 4 times 1 is 4. And then I add up all the scores and I get a score for suburban. I do this for all the cars, and I pick the one with the highest score. So I just made a data-driven decision just using what is called as weighted averages. So I know so many people, they pick a house, they pick an apartment, they pick a school or cost or whatever it is based on this simple idea. It's called decision matrix. So today, my friends, you've learned quite a bit, I'm assuming, hopefully. And hopefully with that decision matrix, I started off with competencies, critical thinking, creativity, communication, collaboration. I moved on to computational thinking skills, which involved algorithmic thinking, pattern recognition, problem decomposition, and abstracting from computation. We talked about the importance of conceptual learning to beyond procedural learning. We talked about how to make decisions. We talked about how to create graphs in a successful way. And there's a lot more. This is just the surface. And believe it or not, all this is in a high school class and below. So if Uganda wants to really make a move in a direction that every state and country the US is trying to do, it's in data science. Here is another final reason why, the dollar reason. In the United States and in the world, the highest paying job is a data scientist on an average. So the question is, do you want to become a data scientist? And I will stop there. Thank you. Thank you, Stephen and Ronald.
Thank you so much, Professor, for the wonderful presentation. Thank you so much. I want to ask members that there is a lot we have learned through this session, and I think this is the time for our country to move from procedural to conceptual learning. It has really been a very good session, and I'm very sure everyone here has learned something. I don't know whether, in case you have any questions or anything that you may want to ask, or something that maybe you may want to know more about the session, you can have it put in the chat, and then also you can send a professor an email and he will be able to reply to you. Allow me now to, Mr. Ronald, are you still on?
Yes, Mr. Kaziba, I'm on.
Okay, I think we have come to the end of this session. I want you to send out to close the session and also to thank our professor for the wonderful.
Yes, Professor, thank you for this section. You talked about computational thinking, and we talked about helping learners to start thinking early. But I think what has come out of this session is to help teachers to start thinking. We definitely must think beyond where we have been, and we need to start on this journey. We need to make a decision on this, and definitely it is the right way to go, Professor, to enable us to start thinking deeper than we have been thinking, and we are going to discuss that. I want to thank you for the session, and friends. That's why we have created the Innovative Teachers Forum, and we are going to guide ourselves towards preparing better for Professor. We have been doing a pilot, and we still have a few months to do the pilot, but also as a ministry to take some decisions along the way. And one of the issues that are coming out today is how do we start to get the teachers thinking so that the teachers can help learners to start thinking early. I want to thank you, Professor, for the wonderful presentation, and to thank everyone who has been on the call. We always have the recordings, and we have all the 3 recordings. I think, Mr. Kaziva, we need to keep sharing the 3 recordings now together so that the members can look back at all the presentations that Professor has just done. I also just want to say, Professor, yesterday I attended a meeting where there is a discussion on setting up STEM schools, or setting up schools that will be focusing on STEM and moving beyond STEM to STEAM. And I think our discussions have come in at the right time. When that discussion progresses, I would love that we prepare a presentation for the Ministry of Education on how we can make use of these centers that have been gazetted as STEM schools, but also to support us as a ministry, probably to make sure that when somebody says they are creating a STEM school, we have the right STEM school for our nation. I thank you, Professor, and we shall keep discussing this going forward. Thank you, Mr. Kaziva. And from my end, I would love to say that this session is now closed until next month. Thank you.
Okay, see you all. Bye.
Bye, everyone.
Bye, Professor. Bye, everyone.
Bye.
Members, bye. Thank you so much for this session.
You're welcome.